Here we have the curve, or part of the curve, y equals 1 over x plus 3. We have a region between -2 and 1, and we want to find the shaded area. Just to recap the basic theory about finding area, we take a strip and we say this strip is of height y and of thickness dx. And if we take dx to be very, very small, then the strip is approximately rectangular and therefore has an area of y, the height, times dx, the width. To explain why we take dx to be small, the region is really this shaped. It's not a rectangle at all. However, if we take it to be extremely thin, and of course we can take it infinitesimally thin, then the curve makes very little difference at the top, and we can say that the strip is rectangular. In order to find the whole area, what we do is sum the individual strips between the limits. Each of the individual strips has an area of y dx, and summation is done by integrating. So we write the area of the shaded region is the integral from x is -2 to x is 1 of y dx, y dx being the area of each of our strips. We have x is -2 and x is 1 while we have y inside the integral. Once we have a function of x inside the integral, we could just write -2 and 1. We know y is 1 over x plus 3. So our integral becomes the integral from -2 to 1 of 1 over x plus 3 dx. If we integrate 1 over x plus 3, we get log of x plus 3. We don't need to use a modulus sign here, since there's no possibility with the limits we have of the log being negative. Substituting in, we get log of 1 plus 3, which is 4, take away log of -2 plus 3, which is 1. Log 1 we know is 0, and therefore the area is log 4.